this whole tilt thing here that I've been doing this past year, I got the idea from Bilu. I'm not kidding.
Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
sound level. Sophia's normal.
Yeah, well, I don't know. What's Sophia's experiment? Tell us what the experiment is.
Who didn't experiment?
What is this?
I think he thinks this is the experiment that you've done.
Experiment?
Already. Measurement.
Measurement for horizontal?
I think I know what you're getting at now with these water levels.
Do you?
You're holding... You've got... Oh, look, sorry. I don't want to speak over anyone.
No, go ahead. If you think the penny's dropped, then please explain it back to us.
Yeah.
No, not so much penny drop. I know what you're getting at, but I think I know where you're coming from now. You've got this mile-long observation with a middle point at the half-mile mark.
No, we have a mile-long water level. We can put a camera at each of those 3 points. So if that's what you want to call an observation.
No, what I mean is the distance between your two greatest distances is a mile, the middle being half a mile.
Yep.
And at each point you've got water levels that are held vertical above the location that they're at.
Yep.
Right?
Yep.
And then the water measures, well, not measures, but the water sits horizontal in the tube. So you know that you're not holding it
that's
vertical.
That's what the tool does. The tool establishes a level horizontal.
And then if you have the idea, like now it's a bit of visualization from that top of the line. Sorry, let me say that again. From that top of the flat water inside the water level, there's your horizontal plane, and you could visualize an infinite plane going out from there. Correct?
No, you don't visualize it, do you? You know that the level at one end is the same as the level at the other end. I mean that's how the tool works,
realize that,
right?
but what I mean is, when I say visualize, I'm not saying you have to visualize to make it level. I'm saying you can visualize a level. When I draw in 3D, I have this kind of like glass-like plane that comes up on the screen and shows me where I'm drawing, right?
Yeah,
so I imagine that drawing out on top of I'm drawing that in my mind out from the level.
Don't change on the z-axis. Zero change on the z-axis would be on a horizontal plane, right?
Right.
Just so we understand, if that's what you do, right?
Yeah.
Okay, so you can visualize a horizontal plane.
Yes.
Well, you just put a water level that it's on that horizontal plane at one end, and the other end of the water level will also be on that horizontal plane, the very same horizontal plane, won't it?
Yep.
Well, that's it. That's what a water level, the tool, is to establish a horizontal plane of reference.
But I think the key here is that it's held vertical from its position, and that's where I feel that my contention comes in.
It doesn't matter to the level of the water, like I explained that before. The water level doesn't really matter the angle of the tube, because the water level will just be level but within the tube on an angle.
It's like tilting a wine glass that's half full of wine.
Yeah.
What happens when you tilt the glass? The water still stays horizontal.
And that's my point, right? That's where the contention comes in.
So the water will do whatever it wants inside the vial. The orientation of the vial does not make any difference to the orientation of the water inside it.
Absolutely.
Yeah.
But that's where my contention comes in, and by that I mean that's where I feel that's where I explain where gravity takes place, with equal force acting upon that water pulling perpendicular to the center of the mass of Earth.
But
That's where
you
that's where my
already said it was
contention comes from.
horizontal earlier.
It will be horizontal, but just like the example from Primate, a wine glass with wine in it, and
But
you tilt it.
you do realise that Scott said it was on the horizontal plane only at the point in the middle where the water level wasn't even there. So how can both ends also be on that same horizontal plane?
Oh, I mean,
Because
the horizontal
if you were
is
to tap
established
one
by
in
the top
the
of the
middle,
water.
if you were to tap one in the middle, that would also be on the same horizontal plane, wouldn't it?
Sorry, when you say tap, did you say tap one in? You mean set one up?
Tap another level into the same tube, and just
Right,
have
okay.
a junction coming off it. Then
Right, I see.
that one,
tap. I
yes,
see what you mean. Yeah.
that would
Okay.
also be on the same horizontal plane, wouldn't it?
See, it was my mistake there. I thought you mean tapping by the tapping gently hammering, and now you're talking about tapping into the water itself. Yeah.
You understand now,
Sorry.
though, don't you?
I do understand now. Yeah.
So if you were to tap one in at the middle, it would also be on the same horizontal plane, wouldn't it?
Yep. It might. Well, it would equalize, I guess.
Yeah.
Would you have to add more water to? Maybe, I don't know.
Well, or would it would equalise out and just lower the horizontal plane? But that all three would be on the same horizontal plane, wouldn't they?
That's true. Yeah.
So, like when you were right, with spot on, went over here earlier that you did actually establish that a water level can establish a horizontal plane.
Yeah, I providing it's at the, not straight off the ground, then as long as it's set up correctly, then yeah, I have no problem. And the idea of the actual vial tilting but still horizontal, I mean, by logical deduction, I've never seen a bulge in my wine glass. Not that I drink wine, but in a wine glass, liquid is always, science of the globe says that water is always conforming to the forces acting upon it, and that's why it's perpendicular.
Yeah. Perpendicular's two straight lines. So if it comes down vertical, then that acting perpendicular, the bottom bit must be horizontal, right? That must be a straight line at the bottom for it to act perpendicular to it. It's got to be a.
I mean, you can
line.
imagine this across. You can imagine this across different elevations, maybe steps. Up and down.
Vertical change.
Exactly. But I mean, that
vertical change would establish a new horizontal plane, wouldn't it?
It would, yes.
That's how they do differential leveling, and they adjust all of those horizontal planes over. You could imagine it like a canal, with the locks being that vertical step up, and then all of the bits of water in between, horizontal, and a step up in the vertical on the lock. All the way from one side of the sea level at one side, up, down, all the way across to the other side, and back down to the sea level again.